Which of the following claims about the bond in the molecular compound HCl is most likely to be true? And then we have like an A through D type of idea here. Is there a partial positive charge on the chlorine atom? The electrons are transferred completely from hydrogen to chlorine. Is the bond nonpolar because hydrogen and chlorine have the same electronegativity? Or is the bond polar due to the large difference in electronegativity between H and Cl? Well, let's see. Now we have a bond, right, between hydrogen and chlorine. And the first thing I would do is just to state what type of atoms these are, whether they're metals or nonmetals. That might help us out a little bit. Now, hydrogen is all the way on the left side of the periodic table. However, it is the only nonmetal that is there. So hydrogen is for sure a nonmetal. Chlorine is also on the other side, but chlorine is one of your halogens. It's also a nonmetal. So we got two nonmetals coming together. What type of bond is that? Yeah, it's a covalent bond. Covalent bonds are between nonmetals and nonmetals. Now, covalent bonds are not as direct as ionic bonds. Ionic bonds are the transfer of electrons. Covalent bonds means that the electrons between the atoms are shared. So we have shared electrons. So in this space, we would have as many electrons as, the bond would need, and generally it's going to be 2 electrons if it's a single bond, and hydrogen gets the 2, chlorine gets the 2. It's shared. So maybe from that we can answer, get rid of a couple of choices. For example, for B, it says the electrons are transferred completely. That's not true. These are 2 nonmetals. They're shared electrons. Transferred completely is your ionic bonds, and that's incorrect. Nothing else that I could really go on this, so let's dive a little bit deeper. Now, when we talk about covalent bonds, there are 2 different types of covalent bonds. There are nonpolar covalent and polar. So maybe we have to find out which one this is. Now, what we can do is we can use the general acronym SNAP, S-N-A-P, where if you have elements across a bond that are symmetrical, that just means that they're the same, you're going to have a nonpolar bond. Now, does this work all the time? No, but it's a good generalization. If the elements across that bond are asymmetrical, aka they're literally different elements, then the bond would be classified as a polar bond. So, I see hydrogen and I see chlorine. These are different elements. So, by our SNAP, would this be polar or would this be nonpolar? Yeah, this is a polar bond. So, we can get rid of this one, because the bond would not be nonpolar, it would be polar. So now we're down to A or D. Would there be a partial positive charge on the chlorine? Now just know that anytime that you're talking about partial charges, that also signifies that you have a covalent bond. So we're on the right track for that. But we just have to find out whether the chlorine would be positive or whether it would be negative. Now this comes from the electronegativity trend. So here's my electronegativity. Whenever you're dealing with polarity, being nonpolar or polar, we go look on our electronegativity trend on our periodic table. I'm representing the periodic table as just a square here, but just know that as we go from left to right, you are greatly increasing your electronegativity. Now, hydrogen would be right around here, and chlorine's maybe right around here somewhere. But the idea is that I went across the pond from hydrogen to chlorine. Chlorine would definitely have a higher electronegativity. I'm just going to say electronegativity. And the meaning is in the word. If you are, or if an atom has a greater electronegativity, negative, would the higher one be negative or would it be positive? Yeah, it would be more negative. So always the higher electronegative element would be more negative. In this case, the chlorine would be more negative. It would have that partial negative charge. The partial charge we use as this like little cute little s. It's called a delta symbol, but you would say like delta negative, we call it partial negative, which means that the hydrogen would have to be partial positive. So in this case, it's not that the chlorine's going to be positive. That chlorine has to be partial negative because it's more electronegative. Which brings us to the answer of D. The bond is polar due to the large difference in electronegativity. And that's true, right? Since they're on opposite ends, the difference in the electronegativity is going to be fairly large. And that's what a polar bond is. So, that's it. What'd you think? I hope this helped. Let me know in the comments. Thank you so very much for choosing this video to watch. Maybe if you're on the website, thank you for using the website. But if you haven't, you should try it out. glazersguide.com. The link is in the description or at the end of this video, where we have tons of practice problems just like this one with video solutions, just like this one. And we have big deep dive concept videos as well to get you through those quizzes and tests that I know you guys are going to ace. So grab your favorite drink, tea, coffee, water, snacks, mine's popcorn, and let's hang out and let's learn, all right? So I'll see you on over there. Thank you so much, and I hope you're having a great day. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.